Okie dokie. We're going to get started here. Thank you so much, everyone, for joining us today. We really appreciate it. My name's Dalton Kramer, and I'm the growth strategist here, and I'll be your host throughout the presentation. So today we're going to talk about where you should specify polymer concrete. So a quick overview of what we're going to talk about. So we'll get into polymer. So for those of you who are joining us for the first time, we'll talk about our polymer concrete solution. Next, we'll move into the problem. We'll do a deep dive into the corrosion problem. Next will be case studies. So we'll talk about real world examples of specifications and project specifications. Finally, we will wrap it up with Q&A. So for those of you who are joining us for the first time, that Q&A chat at the top there, that is where you should put your questions. It looks just like this little toggle. Finally, we'll end it with a quiz, 10-question quiz. So stick around. There'll be prizes for the top 3 winners, and I will explain the rules at the end. So stick around for that. Introducing our speakers here. So we have 2 speakers here today. We have Michael Blackham. He is the National Engineering Director. And then we have Tom LaRue. He is our National Director of Solutions Engineering. Without further ado, I will hand this over to them and just appreciate you guys all being here.
Thanks, Dalton. As Dalton said, I lead our solutions engineering team. We are providing engineering-based solutions to the corrosion problem across the country. If you've joined us on any of the previous webinars, you'll notice the team's a little bit larger now. We've increased by 50%. Very excited to have Daniel Short and Misty Brown join the team. Daniel, a PE based in Raleigh, will cover the Mid-Atlantic, has exceptional experience designing lift stations, which we'll talk about, a very highly corrosive part of the system. Misty, also a PE based in San Diego, covering Southern California, has experience both on the design side and in emergency repairs after natural disasters. They joined the team with Chris, who's based in Texas, has a long tenure at Armorock, experience in the manufacturing and engineering side. Alec, based in Florida, covering the East Coast. Again, a long career at Armorock on manufacturing, engineering. And Drew, based in Salt Lake, who's also been with Armorock for several years on the account management side and now in the customer-facing engineering role. So a diverse group of backgrounds to solve problems, provide engineering solutions across the country. But now I'll hand it back over to Mike, who can talk about polymer concrete.
Yeah, thanks, Tom. So as Dalton mentioned, I'm Mike Blackham, Director of Engineering for Armorock. I've been in the precast industry for 20 years now, so I obviously love precast. And today we are going to talk about polymer concrete. So what is polymer concrete? Polymer concrete is really similar in concept and design to traditional concrete. When you think about it, it has aggregate, sand, and then a secondary material. One of the biggest changes or one of the biggest differences with polymer concrete is we use a high quality sand and aggregate for that corrosion resistance. And then the other major difference is instead of Portland cement and water, which is typically referred to as paste in conventional concrete, we use a special resin binder. And this resin acts as the adhesive or glue that bonds those aggregates together to form the concrete, much like cement paste would do in traditional concrete. The most notable advantage of polymer concrete compared to traditional concrete is its exceptional resistance to corrosion. That's where its strength is, especially in our sewer environments. So this strength really is the major focus of today's discussion that we're going to go into in good detail. Another benefit of Armorock's polymer concrete specifically is the use of fiberglass reinforcement, or FRP, instead of your conventional steel reinforcing. Not all polymer uses FRP reinforcing, but at Armorock, we really think it's important by eliminating that typical steel reinforcing in our manhole structures and using the FRP to achieve a fully 100% corrosion-proof design. Now, this can be important for future growth. One of the things that we've been asked before is, can you core into your manhole structures? And the answer is typically yes. As long as it's structurally sound, The corrosion warranty is still applicable, and we'll get into some more details of why that is. But long story short, it's because we have a fully 100% corrosion-proof material. The last thing that I'll mention is it's not always important, or it is also important to recognize that not all polymer is created equal. Just like there's many varieties of traditional concrete with mixed designs and different performance characteristics, polymer is no different. It can differ significantly as well. It's all about the materials you use and the mixed designs you develop and create, and then the testing that you complete. So later again, we'll discuss some more key specifications and details that ensure that consistency, the performance, and that you receive the product that you designed for and that the application's needed. So let's talk a little bit about some of the good performance aspects of polymer concrete. Because polymer concrete does not use that water and cement paste, it's far less porous than conventional concrete. This can also help reduce porosity and absorption, which can also minimize inflow and infiltration, which some people would refer to as I&I. That lower absorption rate also can improve the freeze-thaw durability by preventing water from entering the material and expanding during those freeze-thaw temperature cycles. Armorock specific structures are also engineered, as you see there, to exceed traditional concrete in both compressive and flexural strength. Our manholes, we build and design them to exceed 10,000 PSI compression strength, 28-day compressive strength, and over 1,800 PSI flexural strength. This is at least 2 times over what the specified value of traditional conventional manholes are. We also have joint systems that are designed for watertight performance. And actually, so industry standard vacuum testing on a manhole is 10 inches of mercury vacuum pressure. We have actually tested our manholes at our facility to twice that. So we have a very, very tight, watertight product. We also have watertight pipe connections, similar to what you're used to seeing with boots. And when required, we offer engineered anti-flotation collars that are designed to address any buoyancy risk issues that you might have on site. Last but not least, most importantly, Armorock polymer concrete is 100% corrosion resistant. It's not a liner, it's not a coating or a surface treatment, but because the corrosion resistant properties of all the materials we use exist throughout the entire structure, it becomes 100% corrosion proof. So this is key for sewer applications. This is what's going to provide that long-term durability that we should be looking for in our sewer environments.
Mike, we had a couple questions come in, and thank you guys. Please fill up the Q&A as we go. But they asked if when the anti-flotation collar is required and if we provide stamped calculations on that.
Yeah, great question. So we have typical standard designs that give, your everyday typical conditions that if you don't have a geotech report or you don't know your conditions, you can look to that standard design. So for example, our standard products for 48, 60, and 72-inch manholes, they go 20 feet deep with a 3-foot water table. That's our standard design with the flotation collars that we provide. If you know that you have site conditions that are outside of those parameters, we will and can provide stamp calculations for your project, absolutely. Okay, so knowing that polymer concrete is a premium product that we just talked about, one might start wondering, well, what's the cost and how much of a surcharge am I going to have to pay to get this platinum product? Well, a common misconception is that polymer concrete is significantly more expensive than traditional concrete. And, while the initial material cost might be higher, you can kind of see it in the graph there. We have the red Armorock manhole as being a little bit more costly up front. While that may be a little bit higher in the beginning, This kind of perspective doesn't reflect the true life cycle cost of a sewer structure, especially with these manholes that are exposed to aggressive corrosive environments. And so when corrosion is a concern, polymer concrete offers substantial long-term advantages for that. Some of these advantages absolutely outweigh the small upfront costs that would be associated with the polymer. A lot of people understand and can do a life cycle cost pretty easy. A basic life cycle cost is fairly easy to do. For example, let's say you're going to go buy a lawnmower, and they're advertising that lawnmower will last you 5 years before it blows up and it costs you $200. Well, next to it is a lawnmower that says it'll last at least 10 years, and that lawnmower's $300. Well, I would hope that most people would look at that and want to choose the better option if possible, because they realize they're getting a product at $300 that will last twice as long as a product at $200. Well, now the thing you got to start thinking about beyond the basic life cycle analysis, and the challenge is, what is that long-term asset planning when anticipating and thinking about future construction and labor costs? I know here locally, our material inflation and labor has just skyrocketed over the last 20 years. I mean, heck, over the last 5 years, let alone the last 20 years. So that's the hard question, is what will maintenance look like? What will labor look like? What will material costs be 20 years down the road, 30 years down the road? So sometimes people don't really go into a life cycle cost analysis that truly gives you the full answer of what you're paying for. So with a polymer manhole, by significantly reducing the likelihood of those potential future problems or repairs or even replacement, what you get with the polymer concrete would be a long-term cost stability, really, because you know your price that you're paying up front. And you get a protection against potential inflation with maintenance and repair costs. And most importantly, what I think of is you get a more predictable total cost of ownership, because you're reducing that risk of service interruptions in the future and potential emergency repairs. So polymer is not just a good material choice. Really, when you think about it, it's a strategic investment in your long-term financial sustainability. So with all that being said, Tom, why else is cost such a concern with people, and what is the true problem why manholes are falling apart across the country?
Yeah, Mike, the long-term sustainability is a key piece of the puzzle, and there's a structural misalignment of risk in a lot of new construction where master plan communities, new developments, the developers are choosing materials based on cost, handing that material over, that new infrastructure over to the city, the jurisdiction to maintain. And now all of a sudden the city has a ticking time bomb of maintenance 10 or 20 years down the road. Whereas what we'll see when we go through specifications, a lot of jurisdictions are going toward requiring the developers to put in premium materials up front so that they don't have to maintain it down the road. So put that risk back on or put that cost back on the developer so the city is not bearing an undue amount of risk. And that helps spread that cost out and changes the life cycle analysis a little bit. But what we see, and Mike hit on this a little bit with the escalating costs, is over the last 50 years, there's been an effort to reduce inflow and infiltration in wastewater systems. So as inflow and infiltration has gone down, the concentration of H2S has gone up. There's less clean water in the system, higher concentration of effluent, leading to a higher concentration of H2S. That's led to an increase in the rate of corrosion. So as the H2S has gone down, the rehabilitation costs have gone up, and over 45% of the wastewater infrastructure is now over 50 years old. So the maintenance costs have been compiling, and then as Mike said, all of a sudden those materials and labor costs have escalated rapidly over the last 5 to 10 years, and the maintenance costs are unsustainable for jurisdictions across the country. The only thing that stayed the same is the use of Portland cement-based infrastructure, and Portland cement is uniquely vulnerable to hydrogen sulfide corrosion, which we'll talk about momentarily as we get into the core of the problem. That'll answer Chuck's question in the chat. So the H2S problem begins as the effluent flows through the storm drain. Bacteria oxidizes into an anaerobic bacteria, oxidizes organic matter flowing through the system and creates H2S. The H2S is released into the manhole atmosphere following Henry's law. So Henry's law states that the partial pressure of gas above a liquid is proportional to its concentration within the liquid. But what that really means in simple terms is imagine your sewer system with the effluent flowing through is a soda bottle sitting in your fridge. If it's sitting stationary, the gas, the carbonation in the soda stays within the liquid, and if you open the soda bottle, there's no mess. If you introduce turbulence to that bottle, if you shake the bottle, you can feel the pressure in the gas area above the liquid, above the soda increase, and then when you open the bottle, it overflows. It makes a mess. My children think it's hilarious. The larger the bottle, the bigger the mess. So in a sewer system, the effluent, the H2S gas stays in the effluent until you introduce turbulence, at which time it releases and spreads throughout the infrastructure. So that's steps 2 and 3. So going on to step 4 is where we see the corrosion actually begin to take place because the H2S enters the atmosphere of the system and feeds Theobacillus, a bacteria that oxidizes H2S and secretes sulfuric acid. Sulfuric acid has a very low pH, around 1, and that is very corrosive to Portland cement-based concrete. The Portland Cement Association states that in general, Portland cement concrete does not have good resistance to acids. In fact, no hydraulic cement concrete, regardless of its composition, will hold up for long if exposed to a solution with a pH of 3 or lower. Sulfuric acid is particularly aggressive to concrete because calcium sulfate from the acid reaction will also deteriorate concrete via sulfate attack. So sulfuric acid, pH of 1, much lower than the 3 or lower in this statement. And then the calcium sulfate, that's the white powdery substance, gypsum, that you see in the picture. This is dangerous and leads to a snowballing reaction because it expands, chips away, spalls away the concrete structure, exposing more concrete to acidic attack from the Theobacillus and sulfuric acid. Also, per Henry's law, and the way the sulfate behaves in the effluent, the sulfate exists in the effluent as H2S, as HS negative, and as S2 negative. As the pH decreases, the proportion of that leans more heavily toward H2S. So the pH is decreasing, the concentration of H2S is increasing, more gypsum's being created, exposing more concrete. It snowballs going downhill, rapidly increasing the rate of corrosion, which we see in the costs of repairing and maintaining infrastructure across the country. You can see a real-world example of this with a study out of Colorado Boulder. This is the pictures in stage 5, which is the actual concrete being attacked. Colorado Boulder placed these cube samples of concrete inside existing manholes in their system. The pH in these manholes was around, the parts per million H2S in these manholes was around 150 parts per million, which is high, but not abnormally high, not what we see throughout the country. We'll regularly encounter structures, highly corrosive structures with ppm in the thousands. So 150 is fairly typical of a structure across the country. You can see in less than 1 year, the amount of deterioration of that Portland cement, leaving just some large aggregate. That is extreme structural deterioration, becomes a danger to carrying traffic loads, and increases I&I. And as we've talked about, it's going to the rate of corrosion is going to increase. So that's the corrosion cycle. So what causes ppm to rise? There are several factors. The Henry's law constants increase with heat and humidity. So higher temperatures, higher humidity, you're going to see higher ppm and higher corrosion. Travel time, the longer the effluent is flowing through a sewer line, the more time for that anaerobic activity to create H2S in the effluent for when it then reaches a turbulent point to be released into the atmosphere. So turbulence would be the third factor. Areas of high turbulence are going to see higher levels of H2S. The concentration of the effluent, we talked about the decrease in I&I leading to increase in corrosion. It's concentrating the effluent, leading to more H2S in the system. Environmental sulfides play a factor. I was just on a meeting this morning with Miami-Dade. Throughout Florida, they have sulfides naturally in their water, so there's going to be more sulfides in the effluent, higher levels of H2S. And finally, chemicals and manufacturing, pharmaceuticals, dairies, breweries, all of those areas see higher levels of H2S because of the chemicals being introduced into the system. All of those areas are an excellent place to use polymer concrete, and that's areas where we see specifications across the country.
Tom, so seeing how bad this corrosion can be, I've seen some manholes myself out in the field that, yeah, they're just falling apart. And I've had the question asked of me before, well, how is polymer proven that it's corrosion resistance and that it's a great product? And it's a really good question because you want the proof. The proof is in the pudding, right? And ASTM is actually, they have a corrosion testing specification, which is ASTM 267. And if there's anyone out there from California or that deals with California, you probably have heard of the pickle jar test. What this test does, the main concept is that you put your concrete samples in 6 different very corrosive solutions. One of those is a sulfuric acid. I think it's 20%, if I remember right.
20% concentration, yes.
Yep, 20% concentration of sulfuric acid. And so you have to soak these samples, you have to soak your concrete samples for 112 days. And during that 112 days, you're doing testing all along the way. But after 112 days, you test for deterioration, product loss, and even structural strength. You have to do a compression break strength as well after it's been soaked. So it's a really harsh test that requires some pretty high expectation for that performance against corrosion. And so then the next question would be, yes, Armorock has completed that testing and we have passed, our polymer concrete has passed with flying colors. And I think there was a question, my questions are kind of not coming through very clear, but I think we might have answered it. Yeah, the biggest problem, and Tom, you can probably hit on this a little bit more, I think you did already, is that hydrogen sulfide issue in our sewer systems.
Yes. Thanks for adding that color there. And the Green Book Committee is actually meeting right now in the process of approving polymer. So it'll be published in there in the 2027 book. I was great at scheduling, so that's ongoing right now. Dalton, if you can go to the next slide. So we've talked about where H2S is the highest. And then we talked about how polymer concrete is an investment in the system and needs to be responsibly, most cost effectively deployed. So we're setting the stage for the specifications. Where should polymer concrete be specified? And the simplest answer is the high corrosive environments, the lift stations, force main discharges. It's one of the reasons why we added Daniel to the team. He has extensive experience in lift stations. He's going to be a vital asset internally in lift station design and in working with jurisdictions across the country on lift station design, because polymer concrete is a no-brainer solution for lift stations. It's a very expensive piece of infrastructure. It's infrastructure that you want to last a long time, and no other solution can withstand the levels of H2S we see in lift stations, force main discharges. Next area is structural challenges. Deep manholes, sharp turns, those become expensive to repair and replace. Excellent application of polymer. And then finally, high risk and critical locations, high economic impact areas. We've seen major distribution centers where it would be very costly if they're shutting down the distribution area, use polymer concrete. Roadway classification, if it's a busy street, busy intersection, very expensive, very detrimental to the community to have to shut down those areas for repairs and replacements. Jurisdictions are requiring polymer used in those locations. Finally, interceptors, large sewer lines greater than 12 inches. That's a prime place to use polymer because those are areas with higher levels of H2S and more expensive to repair and replace, things that you want to do one time, be done with it, and have the infrastructure last for generations. Couple questions in the chat right now. Can you guys make a wet well larger than 16-foot diameter? No, currently 16 feet is our largest structure. We can look at value engineering and using multiple 10 or 12-foot diameter structures if something greater than 16 is required, but 16 is currently the largest. What would be the maximum diameter that's constructible, and how tall can the base section be? The weight of traditional concrete manholes has limited traditional constructability in large diameters. Mike, do you want to talk more about that, or should we save that one for the end and keep the flow going on max diameter and height?
I think it plays pretty good here. I'll
Okay.
quickly answer that one. So, great question. Currently, Tom just hit on it. Our max diameter is 16-foot diameter, inside diameter. And our max height on our base, currently, we can go up to a 10-foot tall base. We are in works of looking at redesigning and seeing if we can go a little bit taller. And then as far as the weight issue goes, that actually plays perfectly into some of what we're going to be talking about here in a little bit on us being able to have lighter sections. So I will save that for later. But because of that 10,000 PSI strength, we do have lighter, thinner walled sections. And then maybe another side note, we are actually also in development of a new form that's going to be able to pour rectangular or square structures. And so we're looking at some different things where we potentially could go much larger with segmental pieces as well. So that might be a stay tuned for the future.
Great. Yeah, so we covered the high corrosive environments, and there's one more area that is a no-brainer solution, polymer concrete, and that's rehabs. And Mike will talk more about rehabs.
Yeah, so you can see the video here. It's going to kind of go through a typical rehab. But, one of Armorock's key offerings is this rehab, this manhole rehab product line. And in many situations, this is really effective because you might not be able to excavate and replace a corroded manhole. It just might not be feasible. So particularly in maybe high traffic areas or hard to access locations, or possibly just the project budget or timeline does not allow you to be able to replace one. So in these cases, a rehab system can really provide the ideal alternative to replacement. And the cool thing is this delivers a full structural product that is corrosion resistant. And as you can kind of see in the video, it actually takes pretty minimal effort up front and cost compared to some of the other solutions out there. So in the video there, you can see the contractors are able to install these new sections directly into the existing failing manholes with pretty limited site preparation. You don't have to excavate and replace or take out that manhole. You can install it right into the existing product. So the process is pretty quick and efficient and very cost effective with minimal disruption to the system. The only additional work that you'll have is the channel or the troughing. Sometimes people call it troughing, but that channel base and ensuring that that base is properly protected against corrosion, and then filling the void between the newly installed polymer manhole and the existing structure. Usually you want to fill that with some sort of flowable fill. And as far as the base goes, we get asked a lot, how do you make the base, make sure it's a good corrosive resistant product? And really most jurisdictions have a good solution for that. So we just urge you to use whatever your local jurisdiction or the project specifications tell you to do. The best thing about these rehab manholes, the Armorock rehab manhole solution, is that it still provides that structural integrity, the manhole, and also we still provide the 50-year corrosion warranty to our product, because even though it's sitting inside another manhole, it is a standalone product that if for whatever reason the existing outside manhole fails, our product is still designed for installation on its own. And so with that being said, I don't know if we had any other questions on that, but we talked a lot about polymer, Tom, so hoping you can tell us where we should specify it and how do we truly get what we need in our systems.
Yeah, that's great. And that's the core of the presentation today after the background information. And so the solutions team, in conjunction with Illinois State University, recently completed a review of over 450 wastewater specifications across the country. All of the states in which there's a jurisdiction with a specification requiring polymer concrete are highlighted in red. You can see it's about half the country. Our current manufacturing facilities near Las Vegas, near Dallas, and near Tampa are highlighted with those dots. Until recent Armorock expansion, that was the core of our sales team. They were based in those areas, and so it's logical that the initial specifications are near those areas. As we've expanded the solutions team and expanded the sales team, Dalton will show the size of that toward the end. We have irons in the fire, specifications in process throughout the country. We've added 3 states this month, several more on the way. Rapid growth, rapid acceptance, and now we will show kind of the results of the review, the specification review. We observed some best practices. We'll highlight those. And what we consider a good spec is something that encourages open competition and is performance-based. As an owner, someone bidding projects and then maintaining a system, you want a performance-based specification to make sure the infrastructure is meeting the performance you desire. You also want a competitive spec so that you're getting the best possible price, allowing competition between manufacturers and contractors. So those were the things that we considered when reviewing this. We broke them into 3 buckets: full specifications, where polymer concrete is required on all manholes and sewer infrastructure; partial specifications, where the jurisdiction reviewed and identified the highly corrosive areas, kind of the most cost-effective approach to using polymer; and then areas where it's just approved as an or equal, which has some challenges that we'll discuss. So this first example is from Queen Creek, Arizona, where they are requiring all polymer or all sewer manholes shall be polymer and shall be 5 feet in diameter. They are future-proofing their system. Queen Creek is a rapidly growing area. There's master plan communities, new subdivisions going in, lots of commercial development in the Phoenix suburbs, and they want to future-proof so that they do not have a wall of maintenance hitting them 10 or 20 years down the road. They're requiring 5-foot diameter structures, so they have room for expansion. Mike mentioned one of the benefits of polymers. You can core through the side of it, add a new line. It does not expose anything corrosive. So Queen Creek's giving themselves that flexibility by requiring the developers and the master planners to use, 1, a structure that will not corrode, and then 2, a structure that has room for expansion going down for years to come, for generations to come. The next example of the spec, this one actually is brand new, hot off the presses. Drew, the solutions engineer in Utah, and McKay got this one across the finish line a couple weeks ago. But Snyderville Basin Water Reclamation District. So Snyderville is in the Park City area of Utah, rapidly growing, and tremendous amount of commercial expansion in preparation for the Olympics coming in 8 years, back to Park City. So Snyderville went with a partial specification. They identified all the areas that we've talked about where H2S levels are high, where they've observed it to be high or are expecting it to be high, and are requiring polymer to be used in those areas. So that's things that we've talked about: manholes with an inside drop, manholes that are depth greater than 16 feet, lines greater than 18 inches, even sampling manholes on private laterals. They want to make sure that all the new residential, commercial, hotels, all that development is providing high quality infrastructure that will last for generations. So this is a great example of a partial spec. The solutions team's working with jurisdictions across the country to identify and list out their highly corrosive areas and write the specification to use polymer in those places. That's where you're going to get the best bang for your buck. I was with a colleague a couple weeks ago in a colder state, and I have family in Chicago. I'm based in Phoenix, but this colleague had a battery-powered winter coat. I live in Phoenix. I am not going to spend money on a battery-powered winter coat. Snyderville's not spending money for a polymer manhole in a less corrosive area. Use their money wisely. Use it where you're going to get the best bang for your buck. If you live in Chicago, buy a battery-powered winter coat. If you're putting in a manhole in a highly corrosive area, use a polymer concrete manhole. Some of the mistakes that we saw as we reviewed. The top example is someone who wanted to follow Queen Creek's lead and require polymer in all locations. They made the mistake of saying Armorock Polymer concrete. We encourage open competition. Say polymer concrete per ACI 548.17. Saying Armorock concrete or proven equal leaves too much room for interpretation for liners or coatings or some of those other H2S preventative measures for saying or making claims that they're equal when the performance history is not equal. When we talk to the owners and operators across the country, they know that there's a difference in performance. They've observed the difference in performance between polymer and other non-polymer attempts at solutions. The example below is even more confusing because they say manholes receiving sewage from a force main shall be Armorock or approved equal, and then manholes within 100 feet of a lift station. That's a good partial spec. The intent was correct, but that should say polymer concrete. It's additionally confusing because they list Armorock as a lining system, which it is not a lining system. It is a concrete structure with no lining or coating. So there's room for confusion there, and then the or equal, because Armorock's listed as a lining, that opens it up for lining companies to say that they are equal per their bill of materials. So we'd like to clean that up, say polymer concrete per ACI, get a performance-based competitive specification. This one redacted per the theme of one of the themes of 2026, covering up the city's name. But the manhole is required to have a form of corrosion protection, or polymer concrete can be used instead. This is not differentiating the performance between a coating system and polymer concrete. We'd like to see these separated, use liners and coatings in the area where the city desires, and then use polymer concrete in the more corrosive areas where the city desires. If it's an equal playing field between polymer concrete and liners and coatings, the contractors and developers are going to use the less expensive option, not the option that's providing the best performance. So we'd like to see some separation in this specification. Going to a couple project-specific specifications. So this one, the engineer of record identified a couple of manholes where they expect more corrosion. There's going to be turbulence there as that line turns. And so those are required to be polymer 60-inch sanitary sewer manholes per MAG standard detail 419. That's the Maricopa Association of Governments detail for polymer concrete structure. There's no or equal that's inherent with the detail. Contractors know what they can bid, the owner knows what they're getting, the engineer knows what they're specifying. This is a great call out on this plan set. Great example of a rehab specification requiring polymer. Both of these structures very clearly identified in the bid documents and in the plan sets where they want to use polymer concrete inserts, not a relining system. There's other areas within this project where they've called out liners, and then they've identified the areas with more section loss in the existing structure where they're going to call out polymer concrete inserts. A poor example of that is another project out to bid where they actually added polymer in a question submitted to the bidder. They allowed polymer inserts as an alternate, but they failed to update the bid items. So there's items in here that aren't directly applicable to polymer, such as repairing the coat or removing the existing coating, the prior coating that failed. We'd like to see that broken out, specific bid items, so that contractors can put in the price of what they want to use, and then the owner can see prices apples to apples, not with bids missing certain items. Just opens up areas for confusion. Finally, this has become very popular in Texas and is spreading throughout the country, but this is alternate bids. So the alternate bid format allows the owner to look at where the price of polymer, the price of an alternative, either project by project, or we'll sometimes even see this structure by structure. So then the owner can review, not just take the lowest bid, but take the bid on where they think polymer will be used most effectively. They can see the price delta, see the specific manholes and the price delta at those locations, and then use polymer where they see fit, where they're going to receive the best bang for their buck. So alternate bids, we're encouraging this across the country. It's very popular in Texas, particularly the Dallas-Fort Worth area. But we expect to see much more of this over the next 12 months as cities want to see what the exact price delta is and what it will cost to use a premium material, and then they can decide, which specific locations they're going to use that as they become more familiar with polymer. So we talked a lot about specifications, and I mentioned ACI a few times. So Mike, do you want to dive more deeply into ACI 548?
Yeah, for sure. Thank you. Those are good examples of some specs and projects around the country. As engineers, we naturally like to gravitate towards wanting to use standards or specifications or codes that help guide our decisions. We don't want to put something out there that doesn't follow an industry standard, and we can't always be expected to know everything about every product. So we rely on those standards to guide us in what we do. And in 2025, last year, ACI released the new specification, as you see here, ACI 548.17 for specifications for polymer concrete manholes. So the industry now has a formally recognized spec that we can use for designing and evaluating polymer concretes for our wastewater systems. So I'm guessing a lot of people, if they've dealt with manholes and precast, you probably know ASTM C478. That's kind of the go-to spec for conventional stormwater manholes. Well, now with the new ACI spec, 548, we have a go-to specification to call out. And as Tom said, put everyone on the same playing field with open competition. So a little bit about this specification. It supports a drive towards more of a performance-based approach. And really, honestly, I've seen this become more common. Locally here with some DOTs, I've noticed it. A couple jurisdictions, I'm seeing it change. And the reason that I see that happening is because as materials and technologies and different design methodologies change, it's a lot harder to prescribe and tell someone what the formulation is or what the materials are. Really, you should be more concerned about what the performance is. And so, for example, a good example of a design build or a performance-based approach, even the cement market is changing quite a bit. So with EPA restrictions and the use of cement, they're changing. They have blended cements now. And so those old specifications and codes are having to update to evolve with the times and changes. So really that performance-based standard is becoming more and more common. And with ACI, some of those that they give for polymer concrete, they give guidance and requirements for manufacturing tolerances to ensure that consistent quality. They give the durability requirements, right? There's durability for corrosion, obviously. There's durability when it comes to the ASTM 267 spec. They give structural performance criteria on how you design your structure and have that long-term durability. And then most importantly, the ACI spec actually calls out that you have to provide a 50-year corrosion warranty with your product. So that's great. And then by standardizing these requirements, ACI helps engineers specify polymer concrete so that we have clarity and consistency and confidence to know that we're going to get the product that we need and that we spec out and that we pay for. Because a lot of this is tax dollar money. And so we really want to make sure we pay for what we get. And kind of with that, I think we had a couple questions here I noticed. One was earlier, I think we answered it, but I'll just address it real quick to make in case we didn't. Is your product recommended for certain storm sewer applications? And the easy, quick answer to that is if you have high corrosion rates, then absolutely. Our product shines the most and is worth that money you're going to spend when there's corrosion concern. I don't know, Tom, if you have anything else to add to that.
Yeah, I'll add. We actually just received a set of plans this week in Los Angeles County, a project in the harbor in Marina del Rey. It's a small storm line. It's an 8-inch PVC storm line and a 48-inch polymer concrete manhole because of the stormwater or the seawater in the area corroding the previous concrete infrastructure. So we do see that. We see that some in Seattle, the Seattle area where they have very high environmental standards. So we do see that. You have to evaluate that, your system as you go to evaluate the performance needs that you need on the specific project.
Yeah, for sure. And then another one, can you precast diversion structures and or slots in channels for diversion gates in your manhole bases? And I love this question. It's perfect timing because I got two good examples. We actually built rectangular intake, outtake diversion structures at our Texas plant that I actually just went to 2 weeks ago. And it has 4 different pipe coming in with 1 going out and then the reverse, 1 going out with 4 going in. And we put check slots in it, diversion gates. So absolutely. And we're actually working on a manhole base, so a round structure. We're working with the customer, I believe in Utah, if I remember right. They asked the same question. And I said, yeah, we can cast a notch, or if you'd rather, because if you need that to be a little more solid, we can go ahead and cast those rails in, the slide gate rails or the head gate rails, or you can bolt that on. So absolutely, that's a good question. And yes, we can cast almost anything you want without getting too far down. We're getting close on time, but just a very, very quick a quick thing here. We have robots that build all of our channel bases and any structure that's needed. So we can get pretty exact and pretty detailed on anything you need.
Then, Mike, there was a question from earlier about the performance. Does polymer concrete experience micro cracking under repeated freeze-thaw cycles, and how does that impact long-term water tightness?
From what I've seen, I have not seen any micro cracking or issues. I know we've walked a couple lines lately. I think just the other day I saw some pictures on some manholes that were about 12 years old of ours, and absolutely zero issues, zero cracking. A lot of time micro cracking, from my experience, comes from that loss of water in conventional concrete, right? You get the cracks because of just durability issues. But I have not yet seen them. I'm not going to say absolutely no, that's not a possibility, but I've not seen any issues with that, no.
And then precast concrete manholes are under ASTM C13 jurisdictions. Are polymer concrete manholes also under this ASTM standard?
I was actually a part of ASTM C13 for years, funny enough, so that's a ironic question. Currently, no, because it is such a different product. Really, the only thing that I know of currently is the ACI committee and the 54817 specification that's driving this.
Yeah, there's several aspects of old concrete standards. The performance aspects we meet or exceed. The more methodological pieces, the wall thickness requirements, things like that, are not applicable because we're meeting the performance in a different way. So that's the ACI is the better document. That's what we're encouraging jurisdictions to write specs based on at this point.
And that kind of hits on a little bit. I'll wrap that up. We hit on it a little bit earlier. It asked about, bigger structures and weight issues. Because of this specification and the way our strength is so much higher, our structures are designed with thinner walls. And so obviously that makes them much lighter. So when we say, oh yeah, we can make a 162-inch diameter or 192-inch diameter manhole, that'd be really, really tough with conventional concrete because you'd probably be in the 10 to 12-inch thick wall range at least. And we're substantially less, and that's why we can ship those and build those and install them, because our product is much lighter.
All right, time for the quiz, Dalton.
Yes, thank you both. I believe that's all the questions in the chat there that have been addressed. If you have any more, feel free to add them. But also feel free to take note of the sales rep that's in your area, their name, phone number, or you could scan the QR code in the corner just for a general inquiry. But we'd love to share more specific information about your area, talk deeper about specifications and projects. So reach out to us. But without further ado, we will get into our 10-question quiz, and hopefully you were paying attention. Okay, so for those of you who have not played a Kahoot with us before, this is a 10-question quiz that you're scored both on how quickly you answer as well as the correctness of your answers. So keep that in mind. You can either go to www.kahoot.it to log in, or you can scan the QR code. But then, yeah, there'll be some Armorock merch for our top 3 winners here today. So it's going to get competitive. So make sure you're answering quickly and correct.
And don't worry, you can put in your username, but the winners will just have you enter your email address in the chat so we can follow up with you with that merch.
Yes, and if you're having any issues with the chat, I'll put my email address in there, so feel free to send me an email. I'll make sure to get you your prizes.
And Tom, just so you know, Dalton did tell me to make sure you knew you cannot join this and win.
Understood.
Give us a few more seconds and then we'll get started.
I should join so I can match you with the Armorock Polo today.
Yeah, 3, 2, 1. Question 1. What are the 4 main ingredients in Armorock Polymer concrete? We have aggregate sand resin FRP rebar, limestone gravel polyester or metal fibers, limestone gravel polyester or metal fibers, or granite silica sand or basalt rebar. Good work, everyone. Correct answer is aggregate sand resin and FRP rebar. Seems like you guys did a decent job presenting. There's a lot of correct answers. We have Sam in first place. Question 2. Which one of these is not a reason ppm rises? We have cold temperatures, travel time, concentration of effluent, or chemical/manufacturing. Correct answer is cold temperatures. We did discuss temperatures and humidity, but cold temperatures was not specifically what Tom was referencing. It was more the hot temperatures. We have Caleb S. in first place. Question 3, true or false? Polymer concrete is most valuable in shallow, small diameter structures. True or false? Correct answer is false. So the opposite of this is more what we were going for. It'd be deeper, large diameter structures, as well as several other areas. We'll have Caleb S. in first place. Question 4, true or false? Polymer concrete is valuable in force main discharge structures because of the high agitation. True or false? Correct answer is true. Yes, so force main discharge, that is one of the key areas because of the high agitation there. Caleb S. still in first place. Question 5. ACI 54817 is blank-based standards for polymer concrete manufacturers to follow. Correct answer is performance. So yes, this is what Mike was talking about with performance-based standards that we and other polymer manufacturers follow. Caleb S. in first place. Question 6. Which of these is a good application for a polymer concrete structure? We have large diameter, lift station, deep structure in a busy street, or all of the above. Correct answer is all of the above. Great work, everyone. Question 7. What product is an equal to Armorock? We have liners, coatings, polymer concrete per ACI 54817, or nothing. Correct answer is polymer concrete per ACI 54817. So to clarify here, so the correct answer is not nothing. Other manufacturers that follow the ACI would also be an equal and allows for competition within the market.
I do like that answer though, so that's okay.
They aren't equal on lead time, customer service, and quality of webinar.
Correct. Question 8. What is an advantage of polymer concrete rehab inserts compared to relining or recoating? We have structural solution, no wall surface prep, 50-year warranty, or all of the above. Correct answer is all of the above. Great work. Brian Glenn in first place. Question 9. Is this a good or bad example of a polymer specification? So we have manholes. All manholes to be maintained by the district shall be Armorock Polymer concrete or proven equal. Good or bad? Correct answer is bad. This goes back to what we were just talking about. We want competition in the marketplace, so we prefer it to say polymer concrete and not specifically Armorock.
And I'll add a little bit to reference the ACI spec so that we make sure we're getting polymer concrete.
Correct. We have BB in first place. Question 10, final question. We have, is this a good or bad example of a polymer spec? So it says all sanitary sewer manholes shall be polymer 5 feet deeper manholes with 30-inch lids per standard detail. Good or bad? For all the marbles. Correct answer was good. Great work, everyone. Thank you so much for playing. So in third place, we have Brian Glenn. Second place, we have Nate. And then in first place, drumroll, we have BB. So thank you guys all so much for playing today. For the top 3 winners, please put your name and your email address in the Q&A chat so that we can get you those prizes. And if not, I will put my email address in there if you have any issues. So you can reach out to me directly. Before we wrap up here, I'm going to share my screen one more time, and then we'll have the QR codes for PDH credit and feedback. So 1 second here.
Please provide feedback. Mike and I will not take anything personally. We try to make each one of these better, more entertaining, more informative. So yeah, please provide feedback on what you liked, what you didn't like, what you'd like to see more or less of going forward.